We are looking for 3 by 3 matrices, and these 3 by 3 matrices, all entries can be either -1, 0, or 1. Then how many such matrices we can create so that the sum of all entries is equal to 5? Basically, we have 3 by 3 matrix means we have 9 entries, and all of those 9 entries can be either -1, 0, 1, and sum of them could be equals to 5. Okay. Now, now 1, 0, -1. These are the three entries. Right. And what does that mean? Let's say if you are considering all ones, right, and total is 5. Total is 5. That means if we consider 5 ones, then 4, then there should be 4 zeros, and there should be no minus ones. Right, because we have 9 entries. 9 entries, if we take 5 of them as ones, then that means uh, 4 of them, remaining 4 should have to be zeros, and the total will become 5, and we have 9 entries here. Total entries is total entries is always 9. So if we take 5 of them as ones, then 4 of them have to be zeros, and minus ones, uh, there should not be any minus 1 entry. Right. Now, similarly, and if the total has to be 5 and all the entries are -1, 0, and 1, then at least there should be 5 ones. Right. If we take only 4 ones, then the total at max will become 4 or lesser than 4. The remaining all zeros, if you put, then the total will become 4. And if you put any -1, then the total will become lesser than 4. Right. So, and the total has to be 5. That means at least there should be 5 ones. That's why I'm not considering any ones which are lesser than 5 ones. Right. Now, if you consider 6 ones, what does that mean? 6 ones, the total is 6. We want to subtract, we want to get it to 5. That means we have to have 1 minus 1, that is 6 plus 1, 7, and remaining two zeros. Right. And if you consider 7 ones, 7 ones, right, then that means total is 7, and to get 5 we have to subtract 2. That means 2 minus 1s, that is 5, and the remaining zeros don't contribute to the addition, right? 7 plus 1s and 2 minus 1s, the total will become 5, and zeros remain. Already 7, 7 plus 2, 9 numbers is already taken, so we cannot have any zeros. Similarly, if we consider 8 ones, then what will happen? 8 ones, then how many minus ones we have? Then we'll have 3 minus ones. But if you consider 3 minus ones, 8 plus 3 is becoming 11. Right. We only have 9 slots. Right. If you consider 8 ones, then we'll have 3. We have to have 3 minus ones to bring the total to 5. Right. 8 minus 3 is 5. But 8 plus 3 is becoming 11. So we cannot have 11 numbers, right? We only can have 9 numbers. There are only 9 slots in the matrix. So clearly 8 is not possible, and anything above is not possible. So we only have these three ways. Right. 5 ones, 4 zeros, or 6 ones, 2 zeros, and 1 minus 1, or 7 ones and 2 minus 1s. Now, how many ways of arranging all of this? Basically, this is equivalent to arranging 9 letters such that 5 of them are same, 4 of them are same. That is equal to 9 factorial by 5 factorial into 4 factorial. Similarly, here 9 letters, of which 6 of them are of one type, 2 of them one type, one another type. So 9 factorial by this 6 factorial into 2 factorial. Similarly, here 9 factorial by 7 factorial into 2 factorial. So this is 126, this is 256, and this is 36. Total all of them is becoming to 414. So the correct answer is 414. Right. So minimum number of ones that we should have is 5, because otherwise the total can never reach 5. And maximum number of ones that we can have is 7, because if we go to 8, then we have to have 3 minus ones, and the total is becoming the total number of digits that we need to make the total 5 is 8 plus 3 is becoming 11. So that is also not possible. So only these three cases are possible.